Welcome to Expert ACM Supply Chain Knowledge Sharing session. In this session, we are going to see a statistical term called Central Limit Theorem. In probability theory, the Central Limit Theorem or CLT states that the distribution of a sample variable approximates in normal distribution, that's a bell curve, as the sample becomes larger, assuming that all the samples are identical in size and regardless of population's actual distribution shape. Put another way, CLT is a statistical premise that given a sufficiently large sample size from a population with a finite level of variance, the means of all sampled variables from the same population will be approximately equal to the mean of the whole population. Furthermore, the samples approximate a normal distribution with their variances being approximately equal to the variance of the population as the sample size gets larger according to the law of large numbers. According to the central limit theorem, the means of a sample of a data will be closer to the mean of the overall population in question as the sample size increases notwithstanding the actual distribution of the data. In other words, the data is accurate whether the distribution is normal or aberrant. Central limit theorem is useful when analyzing large data set. For example, investor can use the central limit theorem to aggregate individual security performance data and generate a distribution of sample means that represent larger population distribution for security returns over a period of time. A sample size of 30 is fairly common across statistics. A sample size of 30 often increases the confidence interval of your population dataset enough to warrant assertion against your finding. The higher your sample size, the more likely the sample will be representative of your population set. Thanks for watching. Bye.